Hello, everyone, and welcome to GPTuesday. Here we are again for another fantastic week. Hello, everyone. Hi. So every week we come together, AI enthusiasts, AI engineers, AI product managers, etc., with many years of experience all between all of us, to learn more about AI so that we can all stay ahead and remain educated in space. So this week we have a very awesome presenter. We have Andres. He's the CTO of bundleIQ. CTO of bundleIQ, doing really legendary work. Working with a lot of potentially collecting all of your data that you need, creating a second brain for you, and being able to interface with that via chat systems or just asking any type of questions between many different LLMs as you desire. And so if you ever need to work with any of your documents and you need to be able to get any type of information from it, all in a conversational way, or please use bundleIQ. So
you say it so much better than I do, man. I'm gonna record this.
Yeah, you could say it much better, I'm sure, right?
Sweet.
But, absolutely. So Andres is going to be presenting on Google Vertex AI. So we're all going to be learning more about how to use machine learning with Google Vertex AI, with image classification for many different use cases that he'll be showing us. And I'm looking forward to learning more about this. So without further ado, Andres, take the stage.
Thank you so much.
Yeah.
Thank you, Grant.
Of course.
All right. How's it going, everyone? I think I'm gonna flip so I can be facing everybody here. So get this passport background over here. How's everybody doing?
Doing great.
That's amazing. So as Grant said, today I'm going to be showcasing Vertex AI. So Vertex AI is
you share screen? You gotta share screen.
Oh, on the studio?
Yeah.
Okay. Share screen. Just gonna do the entire screen. Boom. Then switch it over. All right. So Vertex AI, it's a service by Google Cloud in its attempt to help bring AI modeling and training and creation in a no-code, low-code type of way. But it's a tricky service because you have Amazon Bedrock, which
still not sharing.
Oh, let me. All right.
Do the your
Entire screen.
do the window on the presentation.
Okay.
Not seeing the presentation.
Yeah, it's probably because I need to move it over. Yep. And now. All right. Let me share this. All right. Can you see it?
Give it a second.
All right.
Yeah.
Nothing?
Still just.
All right. Not that pretty, so let's try to make this work. Let's see. Maybe it's the permissions.
Well, yeah. Go back to Keynote. When you see Keynote, it's in.
Mm-hmm.
In real time.
Okay.
Yeah. So try.
Share. So then let me just do just the Keynote.
Maybe you saw it wasn't even showing the Keynote there.
Yes.
Yeah, right there. Share and then
It's not even Postman's not even seeing here. I could share my entire screen, but nothing.
Maybe you put the your Keynote on your main screen. See how that works.
Yeah, it's right here.
Yeah, you can put it on your main screen rather than maximizing the YouTube Studio.
I think I'm not following.
So like put this on you're using multiple virtual windows right now.
Yeah, so I can just I can just eliminate all the other ones and put everything in one. See if that helps.
Yeah,
okay, let's try it again. Window. Yeah. Entire screen. Nothing.
What's Arc tab mean?
This is like just a browser.
I see.
Yeah.
Maybe try entire screen. Yeah, and then maybe if you create a new screen, put the keynote there, just share that screen. Maybe a different desktop. Yeah.
And then, all right, entire screen or window. The thing is, like, it only shows the current one. So anything that's in the current one. So
Yeah. So yeah, put it on the current one. See that.
And then
Because this is maximized. Just don't maximize the studio.
yeah, but it's not like single screen. But I can actually like resize it.
I could just have the live stream go through the phone. If that works best.
Let's see. Yeah, because it doesn't seem to be picking up on. Let's see.
Can you just open the keynote in a Google tab in a Chrome browser? Is that web presentation?
It's I can try, but it's not a native like Google Drive. It's a,
Okay, we could. If this is having too much of a problem, we could move it to the phone, being the live stream. And restart this works.
I don't know if it's gonna. All right.
There you go. You guys ready? Yeah, we're
All right. So it seems to be. Oh, there we go. Well,
Yeah, it's like
I just can't. Yeah, it's weird. Can't really open with.
Oh, now.
Yeah, it's sharing, right? But the thing is that it's not sharing over there.
Yeah, it did.
Yeah,
It did.
it is.
Yeah.
Oh, nice.
There it is.
Should we start over?
Yeah, that's right. You can edit out the.
Yeah.
Cool. Yeah,
Yeah,
you got the webcam going.
But this doesn't work though. It's just stuck. This is the title. That's all it is. So file opened computers. Yeah, because this is not a native. Maybe.
Maybe. I mean, that's the goal. It's like just take one big volcanic eruption. Yeah. Well, the goal is to help make like micro-decisions. So imagine like you're writing somebody to analyze that eruption.
Okay.
Do you have an internet cable?
It shifted a little bit, but I guess this is so. The thing is that I'm not then going to be able to share much of the code.
Yeah.
Right.
I I think like it works on his computer, so I don't know. Maybe it's just a Mac thing.
Could be.
Yeah, let's just do it like this,
Yeah,
and
that's
that's it. 'Cause
Sure, perfect. Sounds good. We'll
Yeah.
just do it through the phone.
It's fine. It's fine. Like what we can do is like periodically we'll just like so like remember we were saying is like just have this here so that people they don't hear just when you're talking just move out of the way so that the webcam gets the picture.
Okay. All right. Sweet. All right. Perfect. So I'll make sure to look that up here in the stream.
Yeah, I'll just leave this here.
Oh, perfect.
I'm on AT&T, not Wi-Fi, so I'm not using up all your bandwidth.
Perfect.
These are all the questions people are asking me.
Awesome. Okay. Here we go. The third time's the charm. How's it going, everyone?
Going well, yeah.
I'm just giving everybody some time to gather some energy, and it's funny because you're a CTO, you work in tech, and that doesn't make you like a little bit better at like knowing your Zoom links and opening these type of things. But I'm glad to see that everybody's doing fine. My name is Andres. I'm the CTO and co-founder of bundleIQ. Thank you, Grant, for that awesome presentation. bundleIQ is a knowledge management platform that allows you to package up all the information that you've ever interfaced with in a very to use and modular system and allow you to create conversational chat bundle interactions with your data and even package it up for subscription. So if you're a thought leader, if you're a content media creator, and you think that you can monetize on your content, there is a way with bundleIQ. You can grab all that information, whether it's coming from YouTube videos, coming from PDFs, coming from handwritten notes, import it into our application, and then you can create a chat bundle off of it, and people can subscribe. You get a lot of great intel on what people are asking, which also allows you to get some insights into how are people consuming your information. But today we're going to be talking about Vertex AI, which is Google's service for all things AI related. And before, Google Cloud used to have all these services scattered across the board, but they seem to make the decision to package it all up into this thing called Vertex AI. So it's actually a conglomerate of services. So the use case that we're going to see today, we're going to obviously, Vertex is a very broad solution. So today we're going to see the use case of generating a image classification with single labels for detecting or diagnosing skin lesions and determine whether they're likely to be malignant or benign. And in the process, we're just going to see all the other services that Vertex has to offer that might not be covered by this use case. And so we're going to see how to load and label the data. We're going to see how to train the model on one of their services called AutoML. We're going to see how to deploy it and have a deployed model on the cloud, and finally, how to serve it and show more of Vertex AI along the process. So first question that I ask myself is, okay, there seems to be two schools here, like folks that are trying to create their own models and host them by themselves, and folks that say, hey, not really worth it. OpenAI is doing a great job. There's already tools like Grok that host a bunch of open source models and allows you to just allow you to use it. Effortless, almost instantaneous. Like, what is the use case for each one of them? And there's actually a couple of distinct things. With AI as a service, meaning I'm just hitting OpenAI and using their LLM and then integrate it into my app. I don't have to think about infrastructure. I don't care how it's deployed, where is it living. You know, these things have gone a long way in terms of latency. So now they're all pretty fast. So I don't need to worry about the infrastructure. They're pretty high quality, expensive models. Just think about the amount of money that it would take to replicate something like Llama 3 and train it, or something like GPT-4o. It would be almost prohibitive for pretty much every one of us. It's safe to say. You get automatic updates. So you're just going about your app, and all of a sudden, you know, Altman just comes up, or Grokman says like, hey, there's a brand new ChatGPT update. It's amazing. And you get to just go to your API change the model that you're utilizing, and boom, you get like better performance, you get like more intelligence and whatnot. But there's a downside to this. Like number one, you get absolutely no control on the training data. And I think we all saw this famous interview on the CTO for OpenAI, in which she's getting asked if the models are being trained on certain type of data, and she sort of avoids the question. But that just opens up the fact that we just don't know exactly what data is this being trained on. And number two, we have no customizability, which we've offset with strategies like RAG, with other types of strategies that are trying to make us fit a standard LLM into our workflows. And then we have self-hosting as another option, which we do have to think about where is it going to live, what type of VM are we going to host it on, what's the resources. Normally, these VMs with the type of power that would makes us pretty happy in terms of latency are very expensive. We need to train these things, which is based pretty much on our own models. As a fun fact for this thing, we did this hackathon a couple of months ago where we actually built this model. This model is based off of the Built in Miami hackathon, the Miami Hack Week hackathon. Sorry, I'm getting all the events mixed up. And we just like spun up a new project, and we started building this thing, and like the billing started piling up, and we're like, how much deeper into the money pit are we willing to go? Because we were pretty much bootstrapping, and we didn't really have credits or anything else. So for this presentation, I was smart enough to create a new account, so I'll get the $300 credit and be able to like have a little more freedom to play with Vertex without having to worry about it. So definitely money and your resources is a limiting factor, especially with startups. We're trying to save every penny, so that's an important thing. If you want to do an enhancement and improvement, you got to pretty much retrain the model. We're going to see some of the tooling that Vertex gives you to help ease this out, but still an issue. If you want improvements, you got to retrain, you got to do work. But you have full control of the training data, and you can do it. You can customize it to your use case. So pretty much, the concept would be that you'd be looking at creating smaller models that fit more specific use cases, and you're not using something so broad and try to fit it into every single use case. So the first thing that it offers, and just to walk you guys through, on the left, you're going to see all the steps that we're going to talk about today, starting for hosted coding environments, jumping into data sets. So how does Vertex go about managing data sets? What tooling they provide? Then we're going to take a look at training the data. How do you train on Vertex AI? Then how to deploy these trained models on the cloud, on Vertex, on Google Cloud. Then how to serve it, meaning how does your users access these models? That's a very common hiccup where there's a disconnect between like full stack developers and data engineers. They're like, I got this model, it's amazing. They open the Jupyter notebook, and then the developer is like, okay, how can we put it on an API? And that's where people start scratching their head, because there's normally a gap there. So Vertex also helps make this tremendously easy. And finally, we're going to touch on the pricing. I kind of made an allusion to that earlier on. And then finally, we're going to jump to questions and answers. So for the coding environment, Vertex shows a couple of options here. You have, I don't know if, raise your hand by a show of hands, who has heard of Google Colab before? Most of us. Amazing. So Google Colab was, I think it's a scholar tool developed by Google to provide a Jupyter notebook-like type of environment, but on the cloud. So the concept is you have to host it on your own computer, so you could even connect it through an iPad or some other form of tablet, and you can very easily collaborate on a single document, which is great for students. And a lot of people will kind of use this as a tool in early stage startup, but it does provide a little bit of security concerns, especially with sensitive business information and algorithms. So Vertex provides this Colab Enterprise that has enhanced security and a little better resources for jumping with more resource intensive type of tasks. It's serverless, so you just like click a button and it spins up a new Colab document, so you don't have to think about that. There's added security, but it lacks source control with GitHub, which is what a lot of us use for source control. It lacks the ability to customize your environment. So if you're looking to get very specific resources to try to get a sense of the performance of a given code in an environment, then it doesn't really give that for you. And then it doesn't really integrate very much into the rest of the tools that we're going to see today. On the other hand, they have this second service called Workbench that is pretty much a hosted Jupyter lab. It looks exactly like Jupyter Labs, and it has all the benefits to it. So it's got added security. You can do source control on GitHub, so it follows like a more standard type of connection with everything else. You can customize the environment you run it on, so you can pretty much set up a VM and run all your Jupyter Notebook documents on this VM, and it integrates with the ecosystem, meaning you can take this code that you develop on Workbench and then train on this model using other Vertex AI tools. What it lacks is a serverless setup, which pretty much means that you need to spin up a VM, and then you're going to be able to run your notebooks in this VM. So I see each one of these as having a different use case. On one hand, we have Colab Enterprise, which is how they call it. Pretty much, I'm running scripts, other types of code. I want to run it on the cloud, but I don't necessarily want to build an API and have to deploy it every single time. It's great for this. Whether with workbenches, I'm creating a custom model maybe. I want the environment that I'm putting the code in to be as close as possible to where it's going to be hosted and where it's going to be trained. And so Workbench is a great environment for this type of use case. So most of them extremely useful, but each one of them kind of has their own like particularity. So let's see it in action. All right. So here we go. I'm going to open up. Oh, so you guys can still see this. Perfect. Okay. So, boom. All right. So how do you find Vertex? Normally in Google Cloud, there's a bunch of services just like AWS and all these other things. I've never even made an attempt. Now I can see that it's pretty easy to find over here, but I always go straight to the search bar, just type in Vertex AI, hit the search result, and I'm here. And so in the notebook section in Vertex, we have these two options that we were talking about. As you can see here in Colab Enterprise, let's click on this first. It's pretty easy. If I want to create a new notebook, I just go straight into this button, create, and instantly it takes a couple of seconds, but I can just bring in and I can just type away. So very easy. If I go to Workbench, let's just save this up or discard the change. If I go to Workbench, it's going to be a little bit more involved. So the first thing it's going to ask, what instance you want to run this on. I don't have one, so I'll have to create a new one. You can just go ahead and continue. I'm just going to go with all the defaults. As you can see, instantly it's a more involved process. So it does cost a little bit, $133 a month for a hosted Workbench environment. Whether it's worth it or not, that's up to you. I think it's pretty expensive. At that point, I'd be like, I'd rather just do this on my own. But it's a tool that they provide, and one of the things that is beneficial to this is that you can later grab this code and go and train it. So these are the two options that it offers. I don't really see here an option to like spin this up from the system help. Maybe it's getting cut here in the create. So it takes a little bit. And then after this is created, this instance is created, then I can just click into this thing and start my first notebook. But it's a little bit involved, but then it's got great integration. So those are kind of like the two types of solutions. This is the Google Cloud was being shared, right? Okay, perfect. All right. Let's see.
Someone to type in the live chat.
Yeah, if you guys are hearing me, were you guys able to see the Google Cloud screen?
Stuff they weren't because you didn't share that tab. Showing what I mean, basically, you're seeing what you shared.
Okay. So I'm just going to do a quick overview of this then real quick for the guys that are connected online. So pretty much you got Colab Enterprise. It is a very streamlined service, allows you to run scripts and other types of things. As you can see, you just click a button and you're presented with a new notebook that you can collaborate with anybody that's got access to this Google Cloud project. And then you have the workbench over here that enables you to have a Jupyter-like environment, but you do have to spin up an instance. It takes a little bit. I created one, like a couple of minutes ago, still haven't spun out. So as you can see, it's got more overhead, meaning like this is going to run 24/7. If I don't cancel this thing, I'm going to get charged $133, which I'm going to stop right now. So I avoid those type of things. We've all had it, right? We do a demo, we do something, and then at the end of the month, you're like, surprise, surprise, Google comes knocking at your door. You get a huge bill. Don't be me. Cancel your instances. All right. Now we're going to jump back into the presentation and talk a little bit about data sets. And then data sets are the life and soul of your models, is the data that you're going to train them on, is the data that you're going to validate them on and test them on. So Vertex offers a very interesting handshake with Google Cloud Storage, in which you upload the data through Vertex AI and you select, we're going to see this in a minute, but you upload the data, whether it's images or text, unstructured text or text, into Vertex AI. It saves all these, all of this data in Google Cloud Storage, but it shows it in Vertex AI. So some of the benefits that this provides is that it's easy export, and Google Cloud Storage is normally like an S3 for the folks that are more used to AWS. Guys, this doesn't seem to be. It shows here, but with Google Cloud Storage still on the cloud. So you got to make API calls if you want to save it or retrieve it, but it's got a lot of tooling for export. So what I'm saying here is that normally with these type of solutions, I'm very wary about vendor locking, meaning you got all your data sets in this like very custom environment, and then if you want to just do it locally or do it some other way, then you're sort of locked in. But with Google Cloud Storage, the good thing is that it's got export capabilities, and it integrates into a bunch of services. So the fact that it's not saving in some obscure type of storage system, but actually something like cloud storage helps export, and you can just interface with cloud storage if you wanted to. The other benefit of this data set management, I've seen some platforms that just allow you to upload all your data all at once. So it's like you get all of this data. In this case, we built the model that we built for the hackathon based off of 1,000 images of skin lesions and a single label where they were malignant or benign. But then with what this allows you to do, we downloaded them in chunks because we had very poor internet, and so it allows you to add your data incrementally into the platform. So something fails, you can rest assured that you can just retry and get all your data in there, which is something that I really value, especially in that type of environment. We didn't have a lot of time to restart the upload many times over, so we'd really appreciated that. And then it gives you the ability to customize other things that folks might appreciate, like how do you want to do the split. You can explicitly state what assets you want to use as training data, what you want to use as validation, what you want to use as test. They have this middle ground that allows you to configure what percentage of the images you want to use for each one of these blocks, or you can just leave the defaults, which I think it's 80-10-10. So 80% of the images is going to go to training, then 10% of those images at random are going to go to validation, and then 10% is going to go for the testing phase. And so let's go check out how that looks. Okay. So here we're in Workbench. Can you guys see Google Cloud? All right.
I think right now it's blank. What did you just try to share?
Google Cloud. So this. I'll try it again. Vertex AI. It seems like so.
It's just a blank screen with your image.
Huh.
Maybe you can just do as a tab.
Yeah, no, I'm doing it as a tab.
Oh, yeah, that works.
Okay, perfect.
No, I mean, not showing now, but it works for second.
Maybe you just got to give it a couple of seconds. I think for the sake of the folks that are here live, I think we're just gonna keep going because we want to make sure to give some continuity to this, and then we'll. All right. Sorry, online folks. We're trying to make it happen here, but some technical difficulties. So this is this data set feature that Vertex provides. So if you want to create a new data set, you can just name it whatever you want. In the selection of the data set is where you indicate what the purpose of that data is for. So it's not just data living on a database, which tell me that Vertex has some kind of under the hood feature generation for the data set. But it allows you to, like, you got to first select whether you're using images for image classification, single label, which is what we use, or you want to do multi-label or objectification and even image separate segmentation. As you can see, image is not the only type of things that you can train on Vertex. You can also use tabular data for regressions and forecasting. You can use text classification with single and multi-label. You can do text entity extraction and text sentiment analysis. And with video, you got a couple of options here. You can do video action recognition, video classification, and then video object tracking. So it ranges across pretty much all the most streamlined data types, and you can do a bunch of things with it. In our case, for example, we use image classification, single image. I'm just going to go with the defaults here. And it allows you to just select file from your computer. So in this case, I'm going to go to the demo. And I'm just going to choose the files from here. We're not going to wait till these things are uploaded. So as easy as this, we are able to get it importing. And the nice thing, these are just images. As you saw, I just selected a bunch of JPEGs that I had stored out for the demo. And then once this is ready to go, then I'm able to then upload a CSV with all my labels referencing the bucket where they're saved. And so you can just grab all your images, get this process started, then sit down and try to label your data, organize your information. Then you can upload it separately as a CSV. So it doesn't require like an all-in type of approach where you got to like upload a whole package with the labels and the files. You can do it in batches. So once this is done, one day, because it does take a pretty long time, it's going to look like this. Apologies for the very gross image. These are the skein lesions that we use as a data set to train the model that we built on Vertex. So as you can see here, they're pretty much all labeled. There is something, thank God I saw this because it's kind of a disclaimer, that we're showcasing the technology Vertex because we thought it was incredibly easy to get these things up and running. Our model is not very good at all. As you can see here, we're already having an imbalance between the malignant type of lesions and the benign. So that obviously makes it less accurate on the malignant type of lesions. So just as a reference, I'm going to show like all the parameters about the model we trained. And I actually had to, I retrained it for this presentation and I trained it on very little hours. So it's not the best model in the world, but I'm just showcasing what the tool gives you, and it's pretty nice that it gives you like a whole layout or where you stand. So yeah, just a quick disclaimer. But you can actually go ahead and even label these things over here. So if you wanted to grab a tool, you can like very quickly change this from one option to the other and save it. So it's got some pretty useful like on the cloud tools for labeling. They used to have a very interesting service, which I think they, as stated here, they're deprecating. But you were able to upload the images, and if it wasn't something like this where you need some medical skill to determine the nature of the images, you could generate a job request to Google Cloud, and they would have humans actually label the data for you. So if it's a simple object detection, like open cans versus unopened cans, you could actually have it like create a job, and Google would pretty much, you could outsource the labeling of the data to Google humans apparently. So something very interesting. Apparently, it was too good to be true because they're deprecating it on July 1st. But we can't have nice things, guys. Oh my goodness. So yeah, it's the labeling service. I will say they need to be doing something under the hood in terms of feature generation for the data sets because, well, this is done. So I could probably show. So these have no labels. And if I go back to the import and I upload a file and I just select a CSV that contains the data with the demo labels, I can probably get these labeled out. So these just have the address of the bucket. So what bucket is it living on Google Cloud? And then it tells you whether these things are malignant or benign. It's a 2-column CSV, so pretty simple. And it's just as easy as that, as getting your data set up and upload it. So no manipulation in Python, which for folks that might not feel comfortable, people may be coming from JavaScript, it's a great feature to have. I will say it takes like, I think for 1,000 images, I had to wait probably like around 8 hours or something to get these things uploaded. So just a word of caution there. All the processes in general related to this takes a very long time. And in the training, you'll see some other hiccups that I encountered. But this is pretty much data sets and how they look like on Vertex. So going now into the third phase of the presentation, which is training a model. Training a model is pretty much grabbing a core model and then passing it through iterations with the data. Yes. Sorry.
So like when you said it takes 8 hours, is that because they're in 8,000? Is there because there are 1,000 individual files rather than a zip file or something?
No, not really. And the reason why I say so is because remember in a couple of slides up, I say that Vertex is using Google Cloud under the hood. Well, I was able to upload those images, and you got to pick a bucket where to store it. So I uploaded all the images just like I did right now, and they were uploaded in cloud storage probably like 3-4 minutes later. So I could see them, and what pertains Google Cloud, I could just manipulate them, and or I could go see them. It all showed as loaded, but this still said like importing. So I'm guessing it's doing some form of post-processing under the hood because it took significantly more. Like as I said, like Google Cloud was all uploaded and ready within a couple of minutes. So maybe it's doing something under the hood, which also like the fact that you got to choose what are you going to use the images for prior to uploading them leads me to believe that they're doing something to prep them up for training. So sorry, I'm gonna make a pause here. We've talked about the coding environments. We've talked about data sets. Does anybody have a question with surrounding those couple of topics?
I'll ask one about the data. I'll speak about it.
I guess you pass it.
All right. Hello, everyone. I've been looking at that kind of data for years, since the days of machine learning discussions and learning to predict. Is there any time-lapse data where the benign lesions begin as something you would ignore, they become more prominent, then they become malignant so that we can train these systems to predict whether this is something you need to pay attention to or not? And if
Yes.
we did have that data, could the system do it? Could you give it sets of data? So it's not a video, it is a group of photographs representing a single lesion.
Right. So to answer the first question, like data availability for this type of information, I think it does exist. Actually, there's this organization called ISIC or ISIC. I don't know how it's pronounced, but it's got a repository of over 80,000 images of skin lesions, and they're timestamped, and they even segment them in several different ways based off of part of the body, based off. And I think there's a set there because it's just a repository of multiple data sets. There's a couple of data sets that are timestamped, and even like age group. So I think you could do something with multi-label image classification, doing some form of feature surrounding the timestamps of the lesions to try to see if there's a time component evolution to these lesions. So I think multi-label image classification alongside some of the data that they provide, or a subset of that data that's timestamped, could work to build something of that nature.
With multi-label, one of those labels is an individual person. Another label is where on the body it would be. Another label could be the timestamp.
Yes.
Exactly.
Or you could build a custom feature, which is an abstraction of individual data points for that image that is some form of KPI that relates to the passing of time. So a skin lesion of certain type with X amount of time from the time it showed up. So 1 month lesion, 3 month lesion, 1 year lesion, and then you can sort of determine based off of the nature of the image and the time that has elapsed since it, pretty much you first saw it. You can kind of get maybe like a better type of relation of what's the evolution of that.
All right, everyone start taking monthly pictures of your lesions under steady light. No daytime, nighttime.
Yeah.
So we visited, that Miami startup Dermasensor. They raised a lot of money to do this type of thing with a hardware sensor, but their thing is like as a tool for actual dermatologists, not to replace the dermatologist. So it gives them like basically probabilities, or basically like an alert about this could be this, could be that. It's not supposed to replace the actual medical knowledge of a doctor, so to speak. So I think like we might be asking too much of an AI at this point to do something like that. Be cool if it could, yeah. If I don't think even if it could, I don't think like the doctors or the medical boards would allow it anyway. So.
Yeah.
We're going to ignore that.
Okay.
And just listen to the good AI systems.
Okay.
Yeah, but that's a fair point. I don't think the intention with this and the motivation was to necessarily replace, but I think a lot of us have ever had this circumstance in the life where you see a weird lesion on the skin. It might be a mole that's looking a little bit different. You kind of see it, you get a little bit worried, but you don't get worried enough. So you're like, I'm going to book an appointment right away with a dermatologist or a medical professional. You just keep seeing the thing and be worrying for months at a time until you get a regular checkup and you're like, oh, by the way, check this out. Do you see anything weird? And they're like, oh, no, you're good to go. This is normal. And then you're like, whew. So this was like aimed to provide like a very low barrier for examination. And if you, I don't know if folks online are going to be able to see the type of response that this generates, but it never does a conclusive diagnosis. It says like, this is likely not something that is malignant, or you should get it checked. We never even like dare to like state a diagnosis. Number one, because we understand that the model is very imprecise based off of the amount of training that we gave it and the amount of data that we had. And then secondly, because it's never going to replace a professional in like a medical examination of the lesion. So the aim was to get that first step of maybe it's not enough for me to go see a doctor, but it's something I can take a picture. And if this thing says that I should be worried about this, maybe it's time to book an appointment. So that's kind of where this tool was aimed to fall under. But that was, yeah, sorry. It's just a hackathon example. So we like the idea came up from one of the folks in the group. We thought it was something relevant that was solving an issue that most of us has actually had in the past. Let's I don't know if Guys online, are you guys still hearing me? I want to make sure that it's all
I'm the only one watching right now, but yeah,
okay.
it's blank.
Perfect.
Fine, but we can edit it with this phone later. Yeah. But just to give like the background, so that dermis sensor, like I suggested that they contact the medical malpractice providers to see if the doctors could get a discount. And it's a good idea, but it was too complicated, to keep it simple as a startup. But in the real world, though, there's a back and forth between either the dermatologist or the plastic surgeon and the pathologist, basically.
Yeah.
So the pathologist would basically, the plastic surgeon or dermatologist will take the skin sample and put it in slides, and the pathologist will slide it up, and there's a back and forth there. So I think the AI could speed up that process, because literally they're handing off like physical specimens, and it takes some time, and there's no reason why it can't be sped up, I think.
Yeah. Not to even like mention that right now we obviously live in a very unique part of the world where we have pretty instantaneous access to medical professionals. So if we were really worried about something, we could probably take care of it within a matter of hours. Just go and visit an urgent care or something of that nature and get it checked out. But like for some other folks in other parts of the world, they might not have such an easy access to uh, you know professionals. So it's a good tool to also evaluate those cases early on and determine whether it's relevant to go make the trip that might be a couple of hours, a couple of days, and go see a medical professional. So, but then again, this was hackathon type of project. So the aim was just to build something around AI and learn tools along the way. So after data set management, you've already say you've generated a couple of scripts on Colab. You have your data, you've explored the data on Google Colab, you know how it's looking like. You decide to go ahead and upload that data to the data sets. And now it's time for training. And with regards to training, Vertex offers a couple of different options. One is like a hands-off, no-code type of solution, and the other one is pretty much a fully custom solution. So with AutoML, that's their no-code solution. So you don't really have any sort of control about any sort of base model that you're using for the training. This case, like I would imagine it's a neural network. They're pretty secretive about what models they use. So I tried looking it up a little bit. It doesn't really show what they use for like single label image classification. I'm imagining it's a neural network of some sort. The data needs to come from Vertex, so pretty much you got to pipe the data through their data set feature. So it's not like, oh, I got this data on an S3 bucket, I got the data somewhere else, or even you can't pipe it directly from cloud storage. You got to pass it through Vertex's data set in order to train on AutoML. On the other hand, with a custom model, you can do your own custom model. You have full control of the layers if you're doing a neural network. You can choose where the data comes from. And this is where Workbench, when I was mentioning, it's got a greater integration. In the training set, you can point to a notebook that contains your base model and like fully custom, like trained without having to do any sort of deployment to any environment. So you can grab the same notebook that you had on your workbooks and train based off of that. And within that, the way that you set up, how is it pulling the data on that notebook kind of determines how do you go about like utilizing the data. So in a custom model, you could pull the data directly from cloud storage. If you want to do it, it's a VM at the end of the day. So you can have the data locally stored in that VM through a persistent disk of some sort, and then use the data from, the disk. I think they actually like advise you to either do it from cloud storage or do it from their data sets. And they actually do something pretty nice in the workbooks, which is that they make all the cloud storage buckets available as if it were like a local file type. So you can just do /GS, and then you have access to all the image buckets. So it makes it like extremely flexible in order for you to load the images to cloud storage and then utilize them for training. And then with the workbooks, they give you like pre-installed VMs that have already TensorFlow. They got scikit-learn. They got other popular libraries you might be building your models on. So with a custom model, you pretty much can, run a pre-configured VM, create your base model, figure out how your training is going to be, and then have it go to this custom training environment in order to train it. So in the framework of this hackathon, with what we went with AutoML, because we are time constrained. Actually, in parallel, there is somebody doing a custom TensorFlow model while we were trying this, because this was more of a backup plan. It's like we need to have a benchmark, we need to have like a base to improve upon. So let's just get something up and running with AutoML. We're trying to do a local model and try to upload it and see if the performance is better. So obviously, the device that we were training locally for that TensorFlow instance. That laptop was resource constrained. We couldn't do it with as many images. And at the end of the day, the AutoML model just exceeded the performance of the custom trained model. But at that time, we didn't know you could actually just upload the core model and have it train on the cloud with computer resources. So let's just see how it looked like in action. So we'll go to Vertex AI. Oh, there's the slides again. Go check this out. And then there's a model development full section where you can run some experiments. You can match the metadata about the models. But we're going to go here to training. This is a little bit of a word of caution here. With everything abstract, it's amazing because you don't have to worry about it until something goes wrong, and then it's not transparent enough to tell you what went wrong. So it's all, very fun, very easy, very streamlined. Actually, in that hackathon project, it was like all in one shot. We were able to get data sets up and running in the first try. We were able to like train a model the first try, deploy it on the first try. So it was very streamlined. As I said, that was very expensive. So after the presentation, we shut it down. When doing it again, I stumbled across, as you can see here on screen, a couple of failed attempts. So I tried all the different variations. So if we hit train a new model and we decide to go to the data set that we just uploaded, which is a demo_live, it's just got 20 images, 10 that are benign, 10 that are malignant. We choose the AutoML, for example. We have a couple of options here. Pretty much the cloud is, listen, the purpose of this model is to have it hosted here on Google Cloud. It's not going anywhere. Is all good. I'm going to use Vertex for everything else. So they offer better performance, cheaper training, and they claim that it's more accurate. If you do it on edge, it's like, oh, the intention of this model might be to export this to an on-device or an on-premise type of thing. It's like it packages up the trained model and the artifacts for you to be able to pretty much serve it somewhere else. They claim it's significantly more expensive. I believe the difference was $350 a node hour, which is their unit of billing for training, versus $18 a node hour. So we're looking at a pretty significant difference there. Just something worth mentioning. But so we have the options of where is this model going to live? How am I going to use it later on? And then what am I going to train on? AutoML, as I said, it's managed all by Vertex. You don't get to control what type of model they use or anything of that nature. But you can also choose, hey, listen, I got my own model. I just want to train on my own. And then it gives you all sorts of very interesting options. Like, for example, it gives you the option of, with it, I've got a model already. I just want to create a new version of it. So you can do that, or you can create a new model. For the sake of this, I'm just going to create a new one. It kind of gives you, yeah, sure, I want to generate some explainable bitmaps for each image in the test. So it pretty much explains its process while training and its parent recognition process. I'm going to select this. Then you get to choose, what type of libraries that you use for the model. If you've already had a container pre-built, which I think, let's see. Oh, so you got to pretty much load all the artifacts and all that stuff into a Google Cloud bucket. So this can get picked up. And I think the workbooks give you the option to export after you pretty much wrapped up your model. So you can select it from
here. Give you all sorts of, parameters for the training container. You can use a pre-built container that they suggest. So that's what all these options are for. But if you go to the container registry on Google Cloud, which is where you can store container images, you can just pick from the list of stuff that you already have. So I think, don't have any of them. So these are the options that it gives you. So pretty much it's like, give me the code, tell it where to host. You can say like here, I can use the data set. I think, yes, in the custom training, you got the option to say no managed data set. And that is if in the case that you're pulling the data directly into the Python file, basically. You say like, I manage my data. I just need a VM to run this. Then you can choose no managed data set. Otherwise, if you wired up the algorithm to go pull the images from the data sets and Vertex, that all of the things that you're seeing on the UI also gets offered in the CLI as a package for Python and other types of languages. So it gives you a lot of options in terms of flexibility. So pretty much for custom models is like what environment you want to train it on and what are the connectors that we need to set up for this. In an AutoML environment, there's very little options, just pretty much where you want to host it. That's the option we're just going to choose. We're going to hit continue, going to train a new model. And just within a few clicks, this is something very interesting, which is that you can do incremental training, meaning you can use a base model that you trained prior to this training as a baseline to keep further training the model. So if you have something that you built initially, say the hackathon, and we wanted to improve upon that model, we could use that as a baseline to keep the training going instead of having to start from scratch every single time and uploading the same images and all that stuff. So for data sets that keep evolving over time, like this lesions, people are going to keep uploading these things to the repository, and we could use newer images or better images to further train and make it more precise. We could do it by enabling the incremental training. Otherwise, they got this couple of options here around like higher accuracy or the defaults. Just going to go with the default and just hit continue. So here is where you get to specify how long are you going to train it for. As I said, the unit of this is node hours, which I'm guessing it's like resources per hour that it's going to be spent. I think the minimum is 8 hours, 8 node hours, which equates, it says estimated completion 1 hour. This is way, way longer than 1 hour generally. Like I think I have the other one running under this same format, and it's still going. And I think it's on like 6-7 hours of training. But you get charged apparently a flat fee of 8 hours. So 8 times $3.5 a node hour. I think that would be like somewhere around like roughly a little bit below $30. But it's as easy as that, as grabbing a data set and starting the training process. This demo live data set is now being currently, it's pending. It's probably on a queue somewhere, but it's probably going to start training pretty soon. This is what I would like, just a word of caution here. Here I have a failed training attempt, and when you click on it, it says like failed with error message, internal error occurred, very descriptive. Please try in a few minutes, of course, because you already waited 8 hours. Then just like wait a few. What's another few minutes, right? I've been tracking the billing. Apparently, they don't bill if you failed, but it's still annoying if you're like, obviously, if you're trying to do something like this, you don't have all the time in the world. You probably need your model for some use case, and you're relying on 8 hours to actually be productive. So, to me, it was pretty frustrating. Got to start all over a couple of times, and thankfully, one of the training jobs actually finished, so I could like use it as a demo. But otherwise, I'd be in a pickle. So, just a word of caution: just like any other abstraction with no code, low code type of solutions, it's all good until something goes wrong, and then you don't have the transparency on what happened and what costed it. If it were if I were to be using a custom model and something would have failed, I would probably be able to look at some form of logs and kind of troubleshoot exactly what went wrong, what caused it. But here, you just got the message, and you got to just go ahead and you lost 8 hours of your life. You got to retry. Obviously, those aren't 8 hours that I just like sat here staring at the progress, but indeed, it's pretty frustrating not to know what's going on. So just a word of caution here with abstracted stuff. It's all good till it's not. So do this at your own risk. But those are the two options, and I'm gonna go back to the presentation and make a little pause here and ask if anybody's got questions around the training.
When it comes to the training data, I'm assuming this lives inside the CSV file that you send with the images, right? But like when we were talking about multi-axis, like multiple fields with the training, I'm assuming that all your data would need all the fields for that to be effective, or not to introduce like major regressions in your detection, right?
Yes.
So in a way, you really can only upload the subset of data of which is fully sanitized. Otherwise, that could impact your training. Now, that being said, what if you introduce a new metric or remove a metric? Do you have to completely retrain the model for that?
So I don't exactly know if that's possible, like removing a field and then sort of modifying the model. My guess would be that you have to retrain the whole thing, or you couldn't like start off of a baseline model if you wanted to do something with another type of field for classification or something of that nature. Because that's just like I wouldn't even know how to deal with that with a custom model, to be honest. Like, my approach would be to start all over, treat it as a different model that has that extra field or that doesn't have that field. So I'm guessing AutoML. Normally, like I'm going to go with the general rule of thumb and say that these things normally allow you to go as long as you stay on their happy path. So I'm assuming that they're not going to allow you to like just like incrementally train a model, or it's going to end up in funky results. So that's probably something that you guys are going to have to test out and do a quick test.
Right. And then just a follow-up question. When we do this, we're using foundational models that pre-exist our training. So really, would it be more accurate to say we're fine-tuning an existing model, or are we literally training a model from scratch?
I would imagine based off of the minimum amount of samples that they give you, that it's a pre-trained model based off of generic image classification. Also based off of what I've seen on other cloud providers, like I think Azure or Azure, I would call that one of the other things that you know they offer these like Azure, okay.
In the US.
Azure.
Oh,
you
I'm from Venezuela. They call it Azure. But yeah, I would imagine. Then again, they're incredibly secretive about what are they using for their process. Like I tried looking up, you know, what like how is the process working? See if I'd have some form of light into what their process is. They're completely shut about it. So I would imagine it's got some form of pre-existing image classification baseline model, because they allow you to get started with a minimum of 10 samples per label. And if you do like a core naked model and you train it on 20 images, it's not going to be like usable at all. At least it's my intuition. I haven't actually tested it, but like I would imagine that it's using the base model.
So if you were to use something like this, I'm just going to say for training or fine tuning, what is the cost compared to just doing something from scratch? So let's say I had, I don't know, a couple million, small voice messages that were a minute or two, or a couple million emails, a couple million texts, a couple million whatever. And I wanted to train it on, good versus bad, or good outcomes versus bad outcomes. What would you expect something like this to cost?
So this is very geared towards images, which I'm guessing it's quite another animal just because of the way that these things are being split up. Like images tend to be pretty heavy. The good thing is that if you actually go to the
Is this only for images?
No, you can actually upload any sort of data sets, including tabular data. And I think they have like a single label text classification, like base algorithm to fine tune based upon. So if we go back to here, and obviously I don't have a data set that's just text, but on the data set fields, if I hit on create and I go to text, that would be a very, like what you're describing seems to be like a single label text classification. So you give it a text and you just determine, hey, this is good, this is bad.
It's called sentiment analysis, and a lot of the existing models already do that. So it would be far more cost effective if you just infer on some pre-existing model like Creator and Mistral, and then just roll with that. And also one thing that you got to also keep in mind is that a lot of people think that they can just like dump arbitrary data into AIs and then just train them to do whatever. But really, in the industry, data conditioning is king. And for instance, if you said that you had a bunch of audio files, for example, you know, those audio files, yes, contain the sentiment of, say, a sales call, right? But they also contain a lot of information you don't care about, which is like the voice or, you know, specifics about background noise. You know, there's a lot of stuff in that data.
I think I might care about that too.
I mean, you might, but it's like, are you really going to draw analysis on, say, you know, somebody having a vacuum in the background? You know, just like arbitrary stuff you wouldn't think about. Because when you train a model, like just outright on raw data, it's going to notice patterns and it's going to cost you the size of that model for things that you don't care about. So what you might prefer to do is actually transcribe those, you know, calls first, and then just do the sentiment analysis on the text of those.
Doesn't work.
But now that being said, does audio work? Does does the opposite work better than what you're saying?
Yeah, I mean that's the problem with the written word. You can't get tone. You can't get, you know, sarcasm. You can't. There's a lot of data you can't get. So just, I mean, back to kind of my question. You know, if you were to do something like this, what would be the cost for, you know, a couple million to do it this way versus trying to train something from scratch, which seems, you know, I was reading $500,000 for an 8 billion parameter model.
Right. So you, as you saw here, like on the training side of things, you can, once you select your type of data, you select RML, right? The last step here is to just set up the budget for it. So it's not a how much is it going to cost, but it's unfortunately, if your main concern is I want to get to this quality, how long do I have to train it for? Because the equation seems to be the other way around. It's like, what is your budget? And then once it's finished training, then you can assess the quality of it. And thankfully, through incremental training, you might be able to do smaller batches of training. Where like if it like you start off with a baseline of some base budget, and then if that doesn't really meet the quality criteria, then you can then like do another session of training on top of that base model and keep improving the model. Now,
So there's no formula, there's nothing that can be used to try to determine cost up front?
well, nothing that will directly correlate the quality of the model with the budget that you have. You can totally decide here how many hours do you wanna run it for, and I think it's got this. Let me see here in training options. I think it's the default. You have an option that says like early stop, which pretty much means that if you're training the model and the model doesn't seem to be making significant changes because of the continuous training, they'll do an early stop even if you set it up for a huge amount of training. So I would say, unfortunately, there's nothing that will correlate that quality. I think it's a little bit the same situation where when you train a model locally, just that money's not really a factor. You're not throwing a budget to it, but you're just training it and then assessing what the quality is once it finished training, and then deciding, hey, do I need to like further fine tune or further train this model, or I need to choose another path. So I would say like an early stop alongside a decent budget might be a good choice if your main concern is getting to like a high quality model. But with these things, and that is the main thing that, makes the biggest noise personally for me about training on cloud. When you're training locally, yes, you're constrained about the machine that you have and other types of factors, but it doesn't become this thing where it's like money against quality, because that's just a formula that unless somebody else has trained on exactly the same data set, same type of model that you have, you just can't know in advance. And so it feels like very high risk to go ahead and allocate all these resources for training of something that you don't know what the quality is for. Like a more fair trade-off, or maybe it's because it's not like dollars, but time, would be to train it locally and see what you get. But in reality, I don't know. Like, I'm gonna open actually this question up for the group here, see if there's any way like to make a direct correlation between the quality that you're gonna get and time of training or something alike. Because I wouldn't know how to relate those two. You guys can think of something?
I mean, I'd assume less than $500,000 if that's what it costs an 8 billion parameter model, but I mean,
Right.
I don't know if we're talking 10 or 10,000.
Dollars?
Yeah.
I don't think so, to be honest. But like, then again, it depends on so many factors, like what type of data set it is, how clean it is, and all those different factors. So
They need to AI the AI. If they're going to run 10,000 of these, they need to evaluate at the end with interaction with the customer. What was the degree of accuracy? They need to look at the data, and they need to be able to give you a prediction based upon the data you're putting in and the amount of resources you're willing to commit, both financially and with time, what kind of results you're going to get. It seems unreasonable to start with a system like this that could be a considerable investment of time and money and not have any idea of what you're going to get. And they already should have enough information to be able to give you some sort of an answer.
That's kind of where I am. I fully agree.
So I think all we have to do is wait until they figure that out.
yes.
So, I mean, I would interject a little bit on that. I think that there's a misunderstanding because we're conflating different types of AIs. When you say, like, for instance, a N parameter AI, that's usually associated with LLMs or large language models, which is a very specific type of architecture of AI. Whereas what you're describing is probably more of a neural net or some variation of a neural net. They have the same kind of fundamental behavior, like on a very low level, but they're not the same thing. So if you take concepts from, like, say, ChatGPT and try to apply that to, some of the earlier AIs that were just their only job was identifying cats and dogs, these are just not the same type of thing. And so what you're, there's like so many stages to like what goes in and what goes out, because your goal is probably to just upload, say, an audio file of a call, right? Like, for example, and what is the desired output, for instance? Is it just, a happy or a sad? Because that is, essentially taking many input neurons, which is essentially representing, some weird interpretation of the audio, and then you have one output neuron, which is just like happy or sad, right? And so what you're going to do is train that model and use it to identify that output. And the thing is that
it would probably be broken down more than that. It'd be broken down to each speech interaction, because you're talking to someone.
Exactly.
It's not one thing.
Exactly. And so, with that being said, it wouldn't behoove you to spend, hundreds of thousands, if not hundreds of millions of dollars worth of training, resources. Instead, what you'd be better off doing is engineering or, essentially putting together a use case of the existing AIs and, you know, kind of chaining them together. And, you know, essentially there are tools like LangChain and all sorts of, you know, integrations. And honestly, that's kind of the whole point of the AI industry right now. You know, there's huge players that make like the foundation models, and they're, you know, just very few high level, you know, companies that can afford to spend crazy amounts of money on A100s all day and then come up with these models that do very specific things and then aggregate them into what we would call GPT, Gemini, etc. No, but what I'm saying is you get what you want more by composing the existing AIs than training your own from scratch. This is my take. It isn't from scratch, but the thing is that has a very specific domain. It's AI, it's image interpretation. I mean, it's the classic, like, is it a cat or is it bread? Or like, is it like a dog or muffin, that whole thing? And so this is what this is. But you're describing something that's like fairly multidimensional. You know, you're analyzing speech, tone, you know, context. You know, that's so broad that you wouldn't just make one model that can just beast all of that. That wouldn't be a good use of your resources. You could, in theory, do that given infinite resources, but it wouldn't be flexible. It wouldn't be iterable. It wouldn't be anything you needed for, you know, to turn a profit on ultimately what you're trying to do. And so I would just recommend that composition of existing models. You know, say you record the calls and you use Whisper to get the transcripts, and then you use maybe some other specialized model which is designed specifically to output a token stream of tone or inflection or something that I'm just not currently aware of. And then what you do is you take those data streams, and those are what you could call like sanitized, and then put those into a trainable model. Because the less data that you put into a model of which you're training, the better your results are ultimately going to be, because, you know, you're giving it more concentrated information, as opposed to giving it all the information and then like just leaving it in the wind. You know what I mean?
I think ultimately it's different types of approaches depending on what you're going to use. Like LLMs are very, I think what allowed everybody to use them is the fact that they're not specialized at all, but you can do like a broad range of actions with a single model. Like you can ask it to write a poem, you can do sentiment analysis, you can do image recognition and do all these sorts of things. But when you build your own models, I think you want to stay as specific as possible. You want to potentially even break it down into multiple models that each one of them does something very specific. And even it's not all is a decision that I'm going to build my custom models or I'm going to use one of the pre-built like foundational models, but it might look just like Gabe said, an ensemble of different things, like part models that are going to extract certain aspects of the conversation that I'm looking for, or foundational models that are going to do that for me. And then I'm going to put that all in a nice table of data with the factors that are all being outputted by those foundational models, and then just run some form of regression or regression model to try to see the output that I'm trying to get to from the results of those, the pre-processing of the data, this sensitization of the data.
Yeah, because there's this phrase in AI, garbage in, garbage out.
Right.
So data conditioning is the process of getting, like, essentially getting the good parts of your data so that you can make, you know, inferences on the parts you actually care about. Oh yeah, I mean, yeah. I mean,
Can I get the mic?
of course, go ahead.
So I have a question. Maybe you have a sense for this, but for example, the hackathon model that you guys trained, right? What's an overall order of magnitude cost for training a model on N images, like what you did?
just allude to what we had, which was 1,000 images. Images are naturally heavy. If you think about what processes of vectorizing probably all the pixels or groups of pixels, that cost us $35 for 1,000 images from 8 node hours, which is the minimum. I think I scaled that up. I was trying to do a type of better training for this one without like any sort of manipulation of the data, just see like how much better can I get with the data set. Same 1,000 images. This time I tried to do it in 40 node hours just to see what type of improvement would I get based off the other metrics, and it failed on the 9th hour. So yeah, I wish I could like I was like eager to exactly show this type of thing to see like okay with a little bit of budget so that we can A/B test how far can we get with more hours. It's pretty much just like just brute forcing more training hours into the same data set, same models, no type of data manipulation.
What was the accuracy that you got with the 8 hours that you used?
I'm gonna show it here. It's right out of the gate. It's very bad, especially on the detection for polygamy. So it's nothing
Super useful.
Yeah.
Okay. I mean, that's fair. It's just I mean,
Eight
just
hours
1,000
is
images is not a lot, right? Like at the end of the day for these models, right?
Probably we have 81,000
Yeah.
ranging type of like I think they all have at least a label of benign malignant. There's like I think this would be way more accurate with a multi-label classification model that would allow you to type in like age and part of the body which the lesion is. So just like speaking a little bit in terms of what could be improved, not on the model side of things, but actually on the data. And these things, I don't think, and then again, I don't claim to be, the almighty of AI, but I don't think there's a whole lot in terms of what model to choose to train the data. So most of the focus that at least I've given is more around how do you clean the data up and how do you make sure that there's an accurate representation of the different variables that we could consider to be directly, in correlation. Like for example, I've seen just out of intuition, and this might be a dangerous assumption, but like areas like the neck, for example, tend to be where these type of malignant lesions tend to happen. So maybe if you add that body component to the, as another label, maybe you can get better results. So,
But is that going to be a one-to-one? So if you say, okay, there's, you're doing 80, right? It's going to be $2,600, right? It's not going to be one-to-one like that, is it?
It's not going to be one-to-one, especially because I would imagine that most of the resources of the training go into the processing of the image itself, not necessarily the label. So I don't think that adding another 3 labels is going to necessarily triple the billing. But something that I would invite you guys to do as an experiment is I think uploading the data set costs nearly nothing. I think uploading the 1,000 images was less than $1. I think it was like 75 cents or 60 cents. So very inexpensive. And with that data set, you can get an estimation of how much you're going to get charged for certain training configurations. So you can actually upload the data set. It does take a little bit, which is a little bit annoying, but if you get that data set in there, when you're choosing the training, you can see, okay, training for this many node hours on this data is going to take about this time. And if you go to the pricing page, you can extrapolate and get a dollar amount out of that calculation.
But I guess the question is, you are supposed to know how many node hours you need, or are they going to estimate it for you?
Yeah, that's going back, like you get to choose how many node hours you want. Exactly. And that was
Just to make sure we have a clear understanding, right? The amount of hours that you put into it is it's like trying to get it incrementally better, because you're like saying, okay, it's 50% accurate, and then it's like 51% accurate, and now it's 60% accurate, and every like hour you tack on just gets a little more accurate until it starts to taper off.
Yes.
And then that's when you say, okay, that's how that works.
Yes, and that's what the early stopping is. If it feels like putting more hours, like it's reading, like it's tapering, it's pretty much flattening in terms of its accuracy, it's just going to stop the process and say, like, hey, we did an early stop because we didn't see that further training it was going to enhance the model inherently.
Yeah, you're getting diminishing returns.
Yeah, but I don't like, and this is, it puts things on a different type of weight because you're directly inputting something you can correlate to dollars. But if you're training a model locally, right? Are you able to establish a direct correlation between the hours that you're going to train a certain model and the data set that you haven't trained before and the quality of that output? I don't know if that's possible, right? Obviously, it's just resources on a computer that you already have, so you don't think of it as much. But I think it's an exercise that could be probably estimated to a certain extent if the data sets are somehow known, but it broadly, like it very much depends on the data set. So I think it's an impossible task to say, I want to get this level of quality, this is how much it's going to cost.
I have another question, different question. So let's say that I wanted to build a model for a specific kind of purpose. Let's say that detecting these lesions, right? Vertex AI is one way for me to go about it, and it sounds like they've got all these options, and most of it is basically hosted on the Google Cloud platform, right? And let's say that I want to spend $10,000 just to train this model. I can a lot of compute hours or whatever.
Google's gonna love you.
Well, here's my question: should I go to Google, or if I'm spending like this amount of money to do it, is there a better way for me to do it? You know, building my own, not Azure. That's not what I meant to ask. I mean, of course, you're going to say that, but I mean, like, you know, if I'm spending this much money, you know, should I spin up my own machine to do it? Should I, you know, like, what's the benefit of the Google Cloud platform if it's not for, you know, just like hackathon, just do this for $30 or whatever, you know?
I think it's mostly the way they set it up, especially on their happy path of like auto ML and the data sets, is to pretty much do a no code, low code type of solution. And you know, in the equation that you're setting up with, should I just like do it on my own machine or actually have a server like and actually do it there? You're not only alluding to the money variable, but you're also throwing in a skill set component. Sure, you could hire it for a skill set, right? But you know, you gotta like think about like not only the person that's got the knowledge on the model and training the model, but normally somebody that knows about infrastructure and a certain degree of networking to get it to like train and host it and all those things. And at least at bundleIQ, we've had like tremendous headaches with provisioning VMs that would allow you to give performant results at competitive prices. And so, sure, if you've got $10,000 to throw in just for the training, most likely you're going to have qualified professionals. But we're already, I think, at the minimum, we're talking about a few folks, one more dedicated to infrastructure and one more dedicated to like actually AI engineering and data science. And that's a component to be thrown. And I think the purpose of Vertex AI to be like as an early conclusion without finishing the presentation, it's great to generate a baseline that you can call it, yes, I have a model that we built. It's not something that's living on somebody else's server. Anybody that's got services that speak to OpenAI and has ever sat on a B2B meeting has had the question, are you sending this data to OpenAI? Are you sending our data to OpenAI? Like what's the security surrounding this? And the truth is that sure, like these are big companies that are probably taking very good care of their security, but at the end of the day, it's not living in your infrastructure. And so if you don't have that skill set to do DevOps or infrastructure or AI, you need a baseline AI component to it. This is a great option to get off the floor as a hackathon project or as an MVP to the startup that gets you some form of accurate model. But I almost see inherently when you scale it up and when it's resources and in your ability to customize the layers in a neural network, that you need to at least move to a custom model where you have greater control, because those are going to be the type of objectives that you're going to be setting up. So I don't necessarily think that somebody's like going to be throwing $20,000 at an auto ML model that you don't know how it's working in hopes that it'll be this awesome thing. Nor I think it's the purpose of the tool either way. I think it's just getting proof of concepts. Even, you know, like Google does some credits that they offer you. So if you've got like, hey, you got approved for Google for startups and you got a $3,000-4,000 to throw around, that's a great use of the credits to build something for your company. But if you've got $10,000 cash that you could allocate any other way, I would imagine that you'd be looking more towards a custom model or another type of setup. So
It's a little like deciding whether when you're making a website or an e-commerce situation, it's like deciding whether you're going to use Wix or you're going to like make the site yourself or you're going to hire a professional to make the site.
Definitely Wix.
That's what I'm saying. It's kind of like this is meant for experiments. It's meant for exploration. It's meant for dipping your toes in AI when you're not necessarily an expert in it. And so it's kind of a way to get your feet wet without necessarily knowing all the complexities. Like you can be like, for instance, a designer. You can make a site on Squarespace, Wix, no problem. But you know, a designer doesn't necessarily know code, and that's why those tools exist, right? But at the same time, if you did know how to code, then you'd actually be in a better position to know if you needed to like actually self-host or make something more nuanced. And so the need to do things yourself will be inherently correlated with your ability to know you need it. And so like at the end of the day, this is nice to, you know, just throw some data in and see what happens to maybe create a demo or to create an MVP. But when you're talking about scaling, you know, to the amount of money that you're like think you would say, oh, I'm going to put $10,000 into this. By the time you're putting $10,000 into this, like you've already put like 10,000 into, say, and hiring an expert who could tell you don't put $10,000 into, you know, into Vertex, please. Oh my God, put it into Azure.
Something else worth mentioning is that this is not necessarily like it could be an end-to-end solution where you upload the data through Vertex, train it in the training system, and then deploy it and host it on Vertex. You can pretty much, I wouldn't say you can start here and well, you could start here, but if you do the edge training, you can export that model and have it hosted somewhere else. If you think if you have a server that you want to host it on, or it's a small model that you want it to live on the device, for example, or you could create your model, train it, and just host it here. So I think what they're trying to do is give you the ultimate flexibility for you to use whatever pieces that you want, depending on what are your unique conditions as a company. You know, you might be like an infrastructure wizard or a DevOps like genius, so you don't really need the hosting of the model. You can just grab the model and host it on the VM or somewhere else and save the money, right? But if you're a startup where there's nobody that knows infrastructure, even though this is under the hood using a VM on whatever cloud registry or container registry or hosting this thing, you could just have it here and deal with the abstraction, which I think it's the general rule of thumb for all cloud services. You got for AWS, Google Cloud, and all these things, you got something that goes from the cloud function on Google, like the Lambda function on AWS, all the way to like an EC2 instance on AWS, or like a VM, pretty much. So you got all the layers of abstraction, and depending on what are the unique conditions of your company or your project in general, not just companies, you get to choose where do you fall in that spectrum. So I think this aims to provide like a broad range of options for you to like use the parts that you want and be on your own for the ones that you don't. And it does have its trade-offs, of course, with the complexity of it. Unlike like Bedrock that offers a very specific solution of hosting, the fact that this is, I think there's another AWS service called SageMaker. I'm not really too familiar with it, but apparently it's something where it allows you to, it helps you build models of some sort.
It's an auto analysis.
Exactly. So these folks decided to combine the two of them into a single service. It does have its pros and cons, so deal with it what you will. So I wish, and then, you know, just by, it's also a good moment to say that I'm presenting this as a tool that we explore and we use for a little bit. I'm not even convinced myself this is absolutely the way to go. Like, this is by no means like a selling pitch. It's just like the result, the presentation of a discovery of this platform, and an explanation of all what it does. I'm not saying this is what you should use by any means. What I would say is really does a great job at is actually in the deployment side of it. And I think this is where there's a lot of hang up in like couple of startups that I've been able to to experience this moment with is that you have data scientists that know like Python very well and know resources very well, and then you got full stack engineers that know like front end and back ends and API, and that's their language and cloud, and they don't necessarily talk to each other. So getting a model from a Jupyter notebook into something that you can query from a mobile application is a gap that seems to be like, at first it seems like there's like, oh yeah, you just host it and that's it, but it's not as trivial as one would think initially. You've got to do export of the notebook and then create an API around it. And in my experience, I haven't found too much people that know both sides of, with enough proficiency to make that happen without two different engineers talking to each other. So I think it's something where this definitely comes to shine, is how easy it is to go from a trained model that's living on a Jupyter notebook into a deployable thing that you can just query that you can just query from a mobile application, from a web application. That was actually one of the main hangups in the process of the hackathon. We had a trained model. It was obviously not as high quality, but in all fairness, it had a lot more merit to have like a custom model that was trained than better performing auto ML model. But there was a gap there in how we host this thing that we didn't have enough time to solve for, and one of the other reasons why we ended up using this. So when deploying a trained model, we already went through the process of maybe built something custom in the coding environments, hosting coding environments, or just simply using AutoML, uploading the data, and then training the data. The follow is, okay, I got my trained model, it's looking good. They do provide some elements in the interface for you to do some level of predictions in their graphical user interface that we're going to see right now, but you pretty much got a choice of, okay, now I need to serve it out to the world. You're not just going to give people access to your Google Cloud project. Every single user that says, oh yeah, I want to get a check. Oh yeah, well give me a Google account and I'll add you to the Google Cloud. That's just not very scalable. And so eventually you end up asking the question, how am I going to serve this model to the audience? And so in Vertex, they offer a couple of options. One of them is edge deployment, is how they call it. Pretty much saying, I want to grab this model, I want to host it on my device, I want to host it on premise, I want to take it out of Google Cloud. Or it's going to live here, I'm going to use it either for batch predictions, which is, I don't really have a use case that's customer facing for this, so I'm just going to stay within the Google Cloud user interface, but I'm going to do predictions of things out in batches. So say like we're at a lab and we want to like pre-process some images, so we don't really need to care too much for the end consumer being able to take a picture, but we get all the images and we get to batch process them through the Google Cloud. So those are the two use cases for cloud deployment, and edge deployment would be more like we're eventually going to take it out. And just as a side note, I was able to train the model that succeeded. I did it through an edge training process, and I was still able to host it in Google Cloud. So it seems like they still give you the opening so that you grab like an edge deployment and still host it on Google Cloud. Of course, they're gonna like say, oh yeah, you want to pay us to host it here? We're gonna allow you to do that. So those are pretty much the two options. So like let's just see it. There's not a whole lot to it more than what we're going to see here on screen. So after you've got your training pipelines here, you go, once something succeeds, as you can see here, we've got a couple of models here in training, a couple of failed, one that succeeded. If we go to the model registry, you're just going to see the one that was able to succeed. And this normally, it says like, hey, it's living here. This is where your model is living. And if you select that model, you can just say deploy and test. And in here, in the testing phase, we can actually just grab an image and process it, a gnarly looking image. We can upload it, and it's going to say that it's benign with 93% accuracy. So even in the case of, yeah, take it with a grain of salt. Okay, this is not medical advice. But what I think is remarkable about this is that it's got a button that says a place when endpoint. And if I say this is live, then I just say one compute node, I can just click this thing. It's just going to start a deployment process where you don't have to think about what's the underlying API? Is there some form of API gateway involved in this thing, pointing to, like, you don't have to think about it. It's pretty much, I'm going to use for sake of time one of the other deployments that I've got, and it just tells you, listen, if you want to do a curl request, this is how it looks like. It's easily translatable into like an Axios call, into a fetch call if you're using a Node API or whatever you're using. You can do it in Postman. You can do whatever you will with it. It's also got a Python package that allows you to just install it and run the prediction directly from the code. So it just makes it that easy to grab a train model and host it so you can serve it to your users. Just the same. Let's see if we can like just do the same image as this one. Go ahead and grab 174.15. This one, it's got to say it's malignant with 90% certainty. And then I'm just like, this is the part that, you know, folks online, I hope, well, I don't hope we're still at 0, but I'm sorry for it. Awesome. But here I am going to go ahead and I've got like a pretty simple Node API running. You guys can see it here. So it's got just a post request that says like, oh, analyze the picture. And this is a hackathon API built in just a few hours, so don't judge on the code structure. But it pretty much, like, this is the part that relates to calling the. You can share this.
Share entire screen, please.
So let me know if it shows up. We're having.
We're gonna edit it.
Yeah. Yes.
Oh, actually, I think that shut down. Ran out of battery. Thought you knew.
So it's just like to show you guys and wrap this thing up like this. It ends up looking something like this. We just got to put like the project ID, the endpoint ID that it gives you, and just like call it predict endpoint. The only reason I'm not calling this endpoint directly from like a Postman instance is because we got to turn the image into a base64, and I thought it was going to be more trouble try to go transform an image to base64 to then like feed it in here, but this is running on local host. So if I go and open a Postman instance that's just like pointing at that, and we choose whatever image we want. So let's see. This is another data set, so I think this will be good to provide. This is how it looks like. And then we just like put it here, just like as a multi-part form data, and we send the response. Then we get a diagnosis of benign with a 96%. And all the extra data is stuff that we kind of bolted on top of the raw response. So if we go to the endpoint controller, there's a lot of things that we're adding in terms of suggestions to the response of the API. Then again, you know, hackathon project, we're in the rush. Mobile applications aren't really known to be fast to iterate through. So we're passing all this data dynamically around, you know, recommendations and what does it mean, and you know, what should you do and all that stuff. But in essence, what we get out of the endpoint is just a prediction. And from the prediction, we get diagnosis, the confidence score, the diagnosis and the confidence score. So it is benign with a 96%. So out of all the fields that you saw on Postman, and I'm going to increase the font a little bit so you can see better. These are the two things that are coming directly from the model. So it just shows that like, you deploy it and you can use it almost instantly. Now, with regards to the data that I know, it would go back to the model registry and check this out. They do give you click on it, and then it gives you all the data surrounding it. Then again, it's got a precision of 87.9, a recall of 87.9. We use 800 images on training data, 101 on validation, and 99 on testing. This is the confusion matrix, as you can see, or can't see. So if we zoom into this, we can see that it really comes to show the fact that there weren't enough malignant samples affects the result. I think ultimately, at the end of the day, it's about the data and how do you make use of it to train a model and be smart about your resources. But the fact that it gives you a little bit of light into the AutoML process that's already kind of an obscure type of process. You don't get to choose a lot of the factors that you normally do when training a model. The fact at least that it gives you the standard data about its performance, it's good. And then let's share just a little bit of data of, then again, just to reiterate, I think I talked about this already. There's pretty much 3 modes that you can use the model moving forward as deployment. You can serve it as an endpoint, which is what we did, what we saw here. So you can query it from anywhere. You can serve it for batch prediction, meaning like it still lives on Google Cloud, but your aim is to feed it a bunch of images and have them, pretty much classify them at scale. Or you want to export the model and host it somewhere else, in which I think it exports everything to cloud storage, artifacts and the weights and everything, so you can later grab that code and host it wherever you can. So we already went through this. I think in the pricing, and we've talked about this a little bit already, but it pretty much, not going to talk about the actual dollar amount because it broadly varies based on the nature of the data, the amount of training you want to do. But for training on AutoML, they charge you by the node hour, which is a unit of processing per time. So it does a lot of parallel processing because you get 8 node hours, and they say it's going to be wrapped up in an hour of training, meaning like it's almost like a unit of resource per time. They parallelize it somehow. In everything else, like a custom ML model is a lot more straightforward. It's what you'd imagine. They charge you per hour of a pre-configured machine. You get to choose what machine you use for this. You get to choose what type of GPU you want to provision this VM with. Same thing goes for deployment. So deployment for these type of services are pretty much based off of a VM. So you host a VM, meaning you're getting charged a fixed amount per month for hosting this. Even if you do it on their managed endpoint, they still host the model on a VM, meaning it's running 24/7, which really helps. I wouldn't imagine how long would it take for a cold start of something so heavy as a model with weights and all that stuff. So naturally, they chose the VM route, but that means that you do have to pay for the hour of the pre-configured machine. But I think they just forward the cost of what the VM would cost in any other service. So if you were to grab your custom model, have it train, have the weights, and host something like a Llama 3 with the weights they give you into a VM in Google Cloud, I think it'd be the same cost. So in that regard, I don't think it's too different from going any other route. But yeah, that's pretty much it. This is an overview of Vertex AI. It's an incredibly comprehensive platform, does a lot more than I showed here, and we're way over time. So I'm just gonna shut up right now, but I just want to open it up for general questions about the tool. Man, I'm so good at explaining.
So I do have another question, and I think you mentioned you don't know this because Google doesn't say it. But Google has built all these models, Gemini, all the various familiar models. Do they give any indication whether any of these models at all are used as part of AutoML as kind of the base model on top of which you do classification or whatnot?
Well, things like Gemini, I think they fall into the LLM category, so I don't really think they could be used as base models for something like image classification. So I'm thinking they got other base models. I will say though, They've got other parts of Vertex that I think it's just too big to cover all in one presentation. But they really, really try to incentivize you to fine tune Gemini in Vertex. They make it extremely easy for you to pick, if you are going the fine tuning route of something like an LLM, to pick one of the flavors of Gemini or Chirp, I think it's their speech to text and text to speech, or Imagen, which is their image generation model, and fine tune those. So just based off of the fact that they have like another session for you to fine tune their pre-configured models, I would imagine they're using something different for the auto ML, and based off the nature of like image classification neural networks, but they do like really push it on other parts of the app for you to fine tune these models. So I would imagine that they do, but I can't say for sure. Then again, alluding back to how secretive they are about like what's actually happening under the hood.
Do you feel the Google models are the same quality as OpenAI? I mean, I was just reading how they were telling you to put glue into pizza and women should smoke 3 or 4 cigarettes a day. There's a couple other examples there, but
yeah, I think that this takes the conversation away from Vertex and more on like on the LLM side of things.
I could go into their images as well.
Huh?
I could go into their images as well.
I think we've all seen what their images generate. But I do think there's like other models that outperform Gemini. And I even think like, it hasn't had tremendous success in terms of its adoption. I see Claude having a lot of success. I even see like Llama 3 in its later release having like very equivalent performance to at least GPT-4. But I don't really see Gemini being part of the conversation.
Well,
then again, that's just my impression.
I've used GPT-4, GPT-4o, Gemini, used a little bit of Llama, and then I've also used Claude. And so I was like actually trying to like figure out which one I wanted to like pay for going forward, because I got a free trial for Gemini. I got Poe, which gave me all the kind of open source models, and then I had ChatGPT. And so I kind of benchmarked them purely on personal preference, purely on like, okay, what worked best for me, what had the least, hallucinations. I was strictly using this for code completion. So what I would do is I would say, okay, how do I accomplish some discrete tasks? And the thing about that is there's usually only one right answer for some specific technical
Make a
question.
green button. So
No, well, because the thing is that if I tell it to make a green button, then there's a lot of ways to make a green button. Meaning that.
But what's your
technically-
favorite?
Well, like basically what I'm saying is that there's a lot of right answers in that problem space. Whereas if I'm trying to, solve a specific programming question, then there might be only like 1 or 2 correct answers. Meaning the target is so much smaller. You know what I mean? It's like hitting a bullseye versus just hitting anywhere on the board. And so, anyway, the conclusion I came to is that Llama, even though I thought it was actually particularly good at code, hallucinated a lot. So I didn't really like that. Then Claude was pretty good. Claude impressed me, including Sonnet, which I was not really expecting.
And that's their middle tier. I think
That's their middle tier.
They got Opus, which is the higher end. They got Sonnet, which is the middle. And then you got Haiku, which is like their small.
Incidentally, I didn't see a huge difference between Opus and Sonnet. However, I only used Sonnet on their app, and then I used Opus on Poe. So I don't know if there was like any prompting differences there. So that could be a thing, but I didn't really see huge differences. I would say that Claude was way more elegant than ChatGPT 4, not O, but 4 specifically. 4 had like if you use it enough, you start to see kind of like patterns in how it tends to answer. It's like the thing is obsessed with lists. I don't even get why. Claude was way more like free form and just answer the question like a person. So if you want to make like if you're using it for like having output that like feels like communication and feels more like literarily nice, then Claude is good. 4.0 complete wildcard. That, I mean, we all saw those like weird demos of it being like Scarlett Johansson stuff. I don't know if that's like way better than GPT-4 base, but in any event, at the end of the day, I just, for sustainability or just like overall use, I just kind of landed back on 4.0. And that's what I've been using going forward.
And I can like speak a little bit because at bundleIQ we use like we have a list of like we actually made it so that you can choose your own model for RAG purposes. But RAG being a RAG, we do impose certain type of restrictions because we backtrack the references that the model uses for its sources because we link them. And so we have some very specific output of how a source should be cited so that we can like put a hyperlink and reference back to the in which we need to have it be each number individually wrapped up in brackets, which is a very specific instruction that we give it in the prompt so that we get the right type of format and we can properly then parse it and link it. And I will say things like Mixture, for example, was very rebel in terms of following those instructions and kind of chose their own formatting, like regardless. In that regard, like all three Claude models have like followed like those rules exceptionally well. We noticed the same thing. GPT-4 is very much about lists and like structuring the data, listing it out, bullet list, numbered list, you name it. It's like very structured, where Claude is a little more articulate. It tends to generate a little bit more content. And just like what you found, Gabe, our default model right now in bundleIQ is Sonnet. Like you're able to change it, but by default, if you open an Elani instance, which is our agent is called, you're going to get Sonnet by default. So just because it offers like the right balance of performance in terms of getting an answer real fast and also quality of result.
It's the best for writing I've found.
Oh, by far.
Yeah,
Like-
Sonnet's really great.
For pros and all that sort
Yeah,
of stuff.
it's really, really good.
So, that was it, guys. Thank you so much.
Just one thing to add, the reason why I landed on ChatGPT-4, because my objective wasn't how eloquent it sounded. My objective was to get correct answers for specific questions. And so GPT-4 tended to deliver to me answers that were actually correct. Maybe they didn't look as nice and were as prettily worded, but they were correct. And that was my main difference. So just want to qualify that.
Awesome. Thank you so much, everyone, for another great Tuesday. Thank you so much, Andres, for that great presentation.
Do you all have a access to
Yeah. You can do that right now.
But, AI
$40
is more
a
than
month
just LLMs.
for
Yeah.
an individual.
Machine learning is deep learning for
It's $250 a month. It's the
wider
base
network.
plan.
So,
No.
anyway, thank you so much
Yeah,
for coming.
if you want
Feel
to-
free to please share on Instagram, Twitter, LinkedIn.
Yeah, that's a lot.
Yeah.
Shoot me a message.
Go ahead and help each other.
Yeah. Audio files,
There's no one size.
images.
But Azure is best.
No.
That's
Even though I work in but right now, the level of hardware you have, so the quality of the GPUs that you get and the cost, when you factor in that, you might be able to get more training hours compared to what you might get on an